Discussing phylogenetic trees, which are graphical representations to show the relationships and degree of similarity between OTUs. So I present to you the phylogenetic tree of pasta. I would like to discuss a couple terms important to keep in mind before we begin to fill in the tree. OTUs are categories that all fit together under one main category or common ancestor. This is an example of a rooted tree where everything in this representation has a common ancestor. Rooted trees also describe that the distance between and order of the OTUs is known. So at the beginning of this diagram, we have lasagna. A lasagna noodle is simply a sheet of pasta, and many different types of noodles can be made by manipulating and reshaping this sheet. Next, the tree branches into two main categories, rigatoni and bow tie. I broke this into these two groups because the rigatoni noodle comes from reshaping the lasagna into a short tube with lengthwise divots, while a bow tie is essentially a shortcut of the lasagna that has been pinched together. So starting with rigatoni, we have elbow and penne pasta. These two are placed together under this category because they are the same tube-like structure of rigatoni. The difference in these noodles is that the elbow pasta is curved, with the divots have been removed, and the penne pasta is the same tube-like shape with the divots, but the ends have been cut to a sharp angle. Arising from the penne branch, we have spaghetti and fettuccine. These branch from the penne category because they are both a penne noodle that has been rolled or pressed into a solid shape. The difference between these two subspecies is that the spaghetti noodles are shaped as a thin cylinder, while fettuccine is a flattened rectangle. Moving on to the elbow group, we have cavatappi and cannelloni. These two are subspecies under the elbow pasta because they both hold the same tube-like structures. Cavatappi is a twisted tube, while cannelloni is a widened, straight tube. To clean up the diagram, I've removed the images and we will focus on the key concepts and terms about this tree. The first term is anagenesis, which describes evolution within a lineage over time. This is illustrated by the entire diagram as a whole, where the common ancestor of lasagna gives rise to all these types of pasta. The next term is cladogenesis, which is the splitting of one lineage in two. This allows for branches to evolve separately from one another, leading to more diversity. Cladogenesis occurs at an internal node, denoted by the red dot at the first split in the graph. Internal nodes of the tree represent the common ancestors of those descendants, so these breaks are internal nodes as well. Two descendants that split from the same node are called sister groups. Next, I'd like to discuss the most recent common ancestor, denoted by a pink star. This describes the most recent individual from which the organisms of the set are descended. Examples of this in the tree include rigatoni, which leads to the elbow and penne, the elbow, which leads to the cavatappi and cannellini, and the penne, which leads to the spaghetti and fettuccine. Lasagna does not get to hold this title because lasagna is the common ancestor of these types of pasta, which is its own term. Finally, I'll discuss the outgroup. An outgroup is an OTU known to have diverged earlier than other OTUs and is denoted by the orange X. The outgroup in this example is the bow tie pasta because it is not like the other types at all. Here's a brief overview of the terms that were discussed in this video, and thank you for watching.